Today in this class we are going to discuss about correlation. We have already discussed the direct method, how we use direct method to calculate the correlation coefficient by Karl Pearson's method. Karl Pearson's correlation coefficient by direct method we have already discussed. In this class we are going to discuss about the shortcut method and we will also discuss the probable error in this class. Let us start the class. I have taken one example here. This is the shortcut method. Shortcut method we have already discussed. It is also known as assumed mean method. Means here we don't know about the mean or central value. So we can assume one value, any value from the series as a assumed mean, and we will calculate the deviation, and after that we will calculate the rank correlation. So let us start. I have taken this question. I have taken two variables x and y, and the value of x 4, 6, 8, 15 and 20, y is 10, 15, 20, 25 and 30. Here we have to, this is the formula for step division method. Sigma of dx dy into sigma of dx dy divided by n whole divided by root of sigma dx square minus sigma dx square by n into root of sigma dy square minus sigma dy square divided by n. This is our step division shortcut method or assumed mean method. So you see the actually how we are going to calculate, what is the formula for rank correlation and what do we need to calculate. So dx dy we need dx equal to x minus a and dy equal to y minus a. A is nothing but our assumed mean. A equal to assumed mean. So any value from the series you can take as assumed mean and you will get the result. Any value, mostly we take the middle value. So take the middle value like this. Okay. Now we will calculate our rank correlation. See how we are going to calculate dx. We need to find dx, then dy. Okay. Then we need to calculate dx dy, multiplication of dx dy we need, with the sigma of dx dy we need. Then we need to calculate dx square and dy square. So this is our table. We need to do like this. First we need to calculate dx dy. Dx we know x minus a. In our direct method we are taking x minus x bar. We have to calculate the mean and then we are taking x minus x bar. Here we are assuming one mean and we are calculating the value y minus a. So see how we are going to find our assumed mean for this case is 8 and for y we have taken 20, the middle value. So you can calculate like this: 4 minus 8 minus 2, 6 minus minus 4. We can calculate 6 minus 8 minus 4. 4 minus 8 minus 4, 6 minus 8 minus 2, 8 minus 8 0, 15 minus 8 7 and 20 minus 8 is 12. Okay, here same way 10 minus 20 minus 10, 15 minus 20 minus 5, 20 20 0, 25 5, then 13 minus 20 10. Here you calculate sigma of dx dy. This is 19 minus 6, 30. This is 0. Okay. Normally we don't need this one, but still we are calculating dx dy. We can calculate here dx into dy, that is minus 4 into 10, 40. 5 into 2, 10. This is 0, 35. This one is 120. So sigma dx dy we can calculate here. Sigma dx dy, which is equal to, this is 50 plus 120 is 170. 170 plus 35, that is 205. This is 205, yes. 205. Now we calculate dx square, dy square. Dx square, 4 to 4, 16. This is 4. This is 0, 49. This is 12, 1, 4, 4. Now for this case we can calculate 100, 25, 0, 25, 100. If you go and adding this one, it will be 200, 213, and this is 125, 125. This is called 250. Yes, 250. So we need to put all these values to our this formula. So let us put it. This is sigma of dx dy, that is 205. This is minus sigma dx, sigma dy divided by n. Sigma of dx dy minus sigma dx sigma dy divided by n, root of sigma dx square minus sigma dx whole square by n. Okay. Same like sigma dy square minus sigma dy whole square divided by n. Minus sigma dx into sigma dy divided by n. Sigma dx is 13 into sigma dy is 0 divided by n. N is our 1, 2, 3, 4, 5. This is 5. Okay. Divided by this one, root of, we can write sigma dx square, that is 213 minus sigma dx whole square, that is 13 square, divided by 5 into root of sigma dy square, that is 250 minus sigma of dy, that is 0 divided by 5. Okay, this is this we have put all the values to our formula, so we can write it here, that is 2 0.05 minus 0 divided by 213 minus 13 square is 169 divided by 5 root into this is 250 root of 250, and if you simplify this you are going to get the value as 0.97. If you calculate the value, you will get 0.97, which is strongly positive correlation. You can write strongly positive correlation between the two variables. So this is 0.97 and 7 is very close to 1, and if it is a positive value, you can say it is strongly positive correlated between these two variables. So this is our, we have to know how we are going to calculate the Karl Pearson's correlation by using, this is our shortcut method or assumed mean method. Let us see how we are going to calculate the probable error in Karl Pearson's method by applying Karl Pearson's method. Let us discuss how we can find reliability of Karl Pearson's correlation coefficient. So to find reliability, we take the help of probable error. Probable error we can find is equal to 0.6745 into 1 minus r square by n. R is our Karl Pearson's rank correlation coefficient. N is the number of observations that is given in the question. So R, Karl Pearson's rank correlation coefficient, number of observation. N is our number of observation. This is our probable error. If the question would be asked to find the probable error, we can go for using this formula and find the probable error, and probable error is we need to find the reliability of the variables. Then standard error, we need to calculate the standard error. Standard error equal to 1 minus r square divided by root over of n. R is rank correlation coefficient and n is the number of observations. If the conditions apply here, if r, modulus of r means r we need to take, if it is positive we need to take positive, if it is negative also we need to take positive, is greater than 6 PE, 6 into the probable error. If r, modulus of r is greater than 6 into probable error, then correlation is taken to be significant. We can say that the correlation between the variables is significant. So we can calculate if the modulus of r is greater than 6 of PE. If r, modulus of r is less than 6 PE, then the correlation is insignificant. It determines the upper and lower limit within the correlation of a randomly selected sample. If you select a sample randomly, also it can determine the upper limit and lower limit of correlation. Means within which the correlation between the variables exists. That also we can find by applying the upper limit as r plus p and lower limit as r minus p. Let us take one example and see how we are going to calculate the probable. By taking the help of probable error, we can solve one question. This is a question of the BPUT exam. I have taken one question. So let us discuss that question. Let me write the question and we'll discuss. question is like this. In a correlation analysis, the value of R and PE means the probable error were found to be 0.9 and 0.04 respectively. 0.9 and 0.04 respectively. Find the value of n. Means यहाँ पर दो वैल्यू दिया है, R दिया है, that is the correlation coefficient value, and probable error also given. You need to find the value of n. So put this formula. We know probable error equal to 0.6745 into 1 minus r square divided by n. So probable error is given here 0.04 equal to 0.6745 into 1 minus r. R is given 0.9, very strong correlation, and divided by n. N we need to find. All the values given actually. Okay, all the values given here. So we need to calculate the value of n. R is given r square, so we need to write 0.9 square divided by n. So see how we are going to calculate it. You can take that 0.04. You can write directly, you can come, or you can write like this 0.6745 into 1 minus this is 0.9 square, this is 0.81, okay, divided by n. This is root of n. Okay. So please rectify the formula, that is 0.6745 into 1 minus r square divided by root over of n. So this is root n. You can write like this. This is 1 minus 0.8. You can write like that. This is, you can write 0.04 equal to this is 1 minus 0.81, that is 0.19 divided by root over of n. So root over of n equal to, you can multiply these two. If you multiply this 0.6745 into 0.19 divided by 0.04, will get to 3.204. Okay, root over of n equal to 3.204, and you can find the value of n. That is, you can make a square of this one, and if you square this one, it is coming 10.265. Let me discuss once again. In a correlation analysis, the value of R and PE were found to be 0.9 and 0.04. Actually, this is the formula to find the probable error, that is 0.6745 into 1 minus r square divided by root of n. Root over that time I forgot to write, so we can write root of n. So we need to find the value of n. Question हमें दिया गया है, the value of r is given and p probable error is given. We need to find the n. N is your number of observations. So directly put it into the formula, that is 0.04 equal to this one, root of n. So you can write 0.04. You can multiply these two divided by n. Okay, and this root of n you can calculate as 3.204. 204, and to calculate n you can make a square of this, that n equal to 10.265. This is the value. So if the question comes like this, you can remember this formula and put it and to find the answer. Thank you so much. I hope this video is useful for all of you. If you like the video, please share with your friends and don't forget to subscribe the channel. Thank you so much.